Hi, thanks for joining me here today at Upstream. I'm Tidelift, and let's get started with the talk. This is Computational Thinking for Creatives, Decoding Barriers to Using Open Source Projects. Let's get going. A little bit about me. I am a design technologist and developer. I have a background in architecture, traditional building design and construction architecture, the one you walk into through a door. I am currently working at HMC Architects Digital Practice, transforming the way we work by using data, code, and other technologies to help make a better building project. And I teach people, in my spare time, how to code. A little bit about where we are going to begin here. At HMC, we needed to teach architects how to code and take advantage of all the new tools out there to make it easier for them to design their projects. Things we couldn't just get out of the box with software. However, a lot of the designers had no idea how to do this stuff. So we had to show them how to do thinking and coding in an intuitive way without having to make it too challenging. And I realized that if I don't explain to people how this works in an intuitive way, then it's not going to work. And the way we do that was computational thinking. And we had to start with learning our audience, what they feel comfortable with, what are we trying to teach them, and how much exposure they had to all this. Creatives, in this case, designers, don't usually feel comfortable with code and text programming. They're very touchy-feely. They like to work with their hands. I like to work with my hands. They're very comfortable with like nebulous thoughts and abstractions. But when it comes to coding, it's a little too technical. It comes off as being almost mathematical, intimidating. They're not familiar with this. So how to reduce that anxiety and make them feel like, they can handle this? Well, we start with patterns. I know everybody loves patterns. There's architecture patterns, there's design patterns, there's coding patterns, there's anti-patterns, there's thinking patterns. This is something we've all run into. And you can see here that we have diagrams for floor plan as patterns, and we have system thinking patterns. Patterns go a long way at helping people acclimate to how to solve a problem or deal with a challenge. So in this case, we followed the computational thinking pattern. And all it is a process in expressing solutions as steps that can be created into algorithms and can be carried out by a computer or some other machine. But it does start with the mind. And you start with using abstractions and pattern recognition. So you have to figure out how to represent the problem. Then you logically organize the information. You break the problem down to smaller parts. You approach the problem using programmatic thinking techniques. You reformulate the problem. You identify and analyze implementing possible solutions, and you generalize the problem. So many people who have been coding are familiar with these steps. When it comes to teaching people with a design background, they can still learn how to use these steps to refine their patterns. And the essentials to cover in the early stages of learning how to do this is inputs and outputs, data flow, data type, and recursion. This is how we prepare people to how to abstract problems of the steps and the fundamentals of data processing. And this is where open source comes in. If it wasn't for open source tools, nothing I'm talking about would have worked for our designers. And amongst them, Python, Dynamo, Grasshopper, and Blender. The two in the middle, Dynamo, Grasshopper, are the real champions. When it comes to coding, they are visual scripting low-code platforms that are used in our 3D modeling. So I'll be switching between the two of them as I show you different examples. And of course, they're all open source and all free, and we can't thank enough of the developers for doing this. And we wanted to do these visual scripting mediums, in this case, example, Blender, to establish computational thinking, because we want to show something that's easy to interpret through a designer, and that's a 3D model. In this case, it's a skyscraper that's kind of just being shaped by the designer's will. And so, okay, how can we make this possible? Something that's really appealing to somebody in this world of design. So we start with some basic premises. And that is data flow. This is very essential. Data flow will also inputs and process. So in this case, we just start with a generic visual example of, okay, how would you make a peanut butter and jelly sandwich, right? You and I would just start like putting the food together, right? But we say, okay, like let's really break it down logically. In order to make a peanut butter and jelly sandwich, as the output, the end result, we start backwards to the end result. I need one slice of bread with peanut butter and one slice of bread with jelly. All right, that makes sense. Usually that's how people do it. Well, I would also need, in the first place, 2 slices of bread. And in order to get 2 slices of bread, I need a loaf of bread that gets cut. But I also need to start with the input of a loaf of bread. You can't just have a loaf of bread and cutting it. You have to start with a knife and a loaf of bread. after you have the bread available, and same with the peanut butter and jelly. When you really put them through this rigor of what the input process output is by working backwards, they start getting it. It's visual, it's easy to follow, it's kind of fun, anybody can get it. And then we kind of take it into what we have here with the Grasshopper tools and say, okay, now let's actually put it into something we can use. Same concept, I want to get coffee. So we figure out what the inputs are: water, heated, coffee, and a cup. You put the coffee and cup together, we heat the water, we put the water in the coffee cup, and then we pour a size of 12 ounces and we get the coffee cup. And this is a great way to learn how to use Grasshopper's visual coding platform. It's a structured environment, it's formalized. We're not talking any real code yet, it's just diagrammatic, but it's an easy step into it. And we take it to the next level, in this case Dynamo, the other open source tool. And we're actually literally going to create a building this time. X, Y, and Z coordinates, 4 corners of a floor, and we're going to multiply this by 100 floors in order to get a tower. So all I have are coordinates, the wall types, the level types, and floor types. We process that, we put them all together, we modify the attributes, we get 4 coordinates put together into one piece of geometry, and then we apply the materials to that. And the output's going to be floors and walls. So to somebody who understands buildings, this is very straightforward and easy to follow. And the result is I get this, a wireframe that says, okay, this is what it's going to look like in a wireframe, and then the output on the right is a literal representation in our software to show that you have over 100 floors ready to go, ready to use, ready to document, ready to dimension in your model. And to this is magic. To them, like, oh, I get it now. I understand what we're doing here. This is the connection. You're removing those barriers. You're showing them what's possible with some very simple inputs and outputs in a visual medium, then get them results they want to get. And then from there, you can have a lot of fun with it as you get a little more sophisticated. It's like playing with clay, trying out different options and surfaces, and they just eat this up. This is like amazing to them. They can finally try things they couldn't do before, because the software tends to just kind of box you in, literally. Whereas in this case, you can really play around with it, and people are just excited at the possibilities, what they can do. Visual, almost like you can touch it. And in this case, with this Grasshopper example, we can go further, and using that same concept of inputs, process, outputs, you can create some cool interwoven geometry. And they can say, okay, what are my inputs? My inputs is a type of geometry. What is my output? It is going to be a series of points connecting to each other. And from there, once they get the results, they can play around with it some more. They can refine it. And this is where the recursion comes into play. Once they understand the process of inputs, process, and outputs, they can start refining the code, make it smoother, get the end results a little more concise. And they start learning the very fundamentals of how coding works, the very fundamentals of how to put things together in a program. And from there, we can say, you guys are so good at visual scripting, you get how these nodes come together in these wires. Well, how about we show you something like Python, which is a very simple programming, high-level programming language that could take something in that blue area we're seeing here and refine it into that much text on the right. And once you show them this, like, oh wow, really? That's what's possible? I could take something as long as that and just put into a few lines of code, and then they finally clicks in their mind that this is possible. If I started them off on Python, if it was just Python from the get-go, I would have lost them immediately. Maybe a handful of people out of the hundreds I would have shown this would have been interested. So I couldn't just, this is going to be a barrier. This is the barrier we're going to remove, is this kind of interpretation factor. We have the visual scripting, show them all the logic with the computational thinking, and get them to this point where coding is attainable. And that's where you ease them into it. And from there we have some course goals of making sure they learn what they need to learn for parametric design, computational design, generative design. These are all tracks we created, tailor-made for the kind of efforts we're driving towards. And we have to be mindful of if they're visual, audio, texture, or touch learners. Very many of them are visual learners, and they do like to touch. So we try to focus as much as possible on interaction and make it as visually pleasing as possible. If you went down the road of a traditional coding training, they would be totally lost, give up, or they just wouldn't have time. So you have to make it very accessible to them. And here's a great example of what's possible. This is a real building we're designing, will be built soon. It's a library with a facade that faces the south, so it gets a lot of solar gain, and we wanted to design it so it was responsive to the environment. On the one hand, we didn't want to make it a sort of monolithic looking shading system, which you might see in these kind of buildings. On the other hand, we didn't want to take forever designing something a little more unique, so we used all these principles of computational design to then design their buildings. This is the whole end result. It wasn't just for fun. It was to design buildings for them. And so we took the same concept of how do we study solar gain and make the right kind of panel, and this is all done by the architects in-house. And it was by this system we showed with Grasshopper, the open source tool, which is inputs, process outputs. It's a little more sophisticated. There's a lot more going on here. I won't go into details, but once you master that logic and once you know and once you get comfortable with it, you can really get a lot done. And these kinds of visual scripting can get a lot done. And in this case, we got both environmental analysis of how much heat gain we have in the room, so we can justify our reason for designing a certain way. On the right, we have the kind of panels we want that can control the heat gain and the lighting in the way we want. So on the one hand, it's a comfortable space. On the other hand, we don't use too much energy from electric lights. But we can also have a diverse way of designing the panel systems, so we don't just kind of have a hackneyed kind of repeatable patterns. It's more of a diverse pattern, responsive, solves the problem. It's computational. This was exactly what we're trying to show people how to do, and we did succeed in doing this in a project. When people see the end result, then they get it. It comes full circle. How we make architects better at what they do. Use the coding tools. Use the computational thinking. This is all bespoke for the project, so it wasn't like we could pull something out of our back pocket to show them. It was just how do we think through the process. And the open source tools, the thinking, and the training is what gets them there. Couldn't do it without a great team. This is our HMC digital practice. We lead by example. I have a link at the bottom if you want to see more, but you do need a team. It takes a village to raise a coder. And to follow up on the key concepts here, coding computational design is more important than for the average person today. We can't hire a whole team of programmers. That'd be awesome, but so we could teach everybody at our company who's already good at design how to design better with these better tools to save time, get better results. We want to create a compatible training style to get people comfortable with the concept. It can't just be here's a stack of code, videos or whatever. We have to show them, okay, here's how you can code for a building. But we have to establish a computational thinking process in the first place. Otherwise, they wouldn't click. You have to be sympathetic to remove that barrier of, okay, how can I even use these tools? Use the resources compatible to trainees, visual, audio, whatever you need to do. Reduce the anxiety with examples that are easy to follow. Create a structured course so they can level up, like I showed you earlier, working backwards with the peanut butter and jelly to the coffee example to the more sophisticated modeling examples to finally getting something a little more production ready. And let them try things out, work on projects, ask questions, and review, upgrade, and continue training forever. This thing will never stop, so we don't want to get them thinking in their head that it's just going to be, you learn a software and that's it. We're past that point. But the open source tools have made a big benefit. I could not have taught this without open source tools like Grasshopper, Dynamo, Blender, Python. These made a difference. Before we only had corporate tools to work with that, granted, integrated these tools into their platforms, but we needed them. We needed tools like this, the community behind them, the accessibility for these from these kind of tools. So please take care of the maintainers wherever you are. Amongst these are all the links to the different examples and more I have. Please support them. I try to support them as much as possible myself. And special thanks to the developers out there for these tools. I learned a lot from them, and it's always a blast to work with them, especially the Dynamo team, the Grasshopper team, and many people who work with these tools to make them better. And that's it for me. Here's my contact information. If you want to learn more, I swear that QR code is not going to be a phishing scheme. So thanks for hanging out my presentation. If you have questions for me, Tadia Kopian, let me know. I'll be hanging around for a while. Thanks, everyone. Appreciate it.